Good morning. I think it'd be nice to talk about a t-test. So the t-test that we use in biology class is actually called a student's t-test. And what a student's t-test does is it takes two sets of data and it compares them to see if the means and the variance of these two sets of data are different enough to say that your two sets of data are different from each other. If the means and variance overlap enough, you could say that the difference between your two sets of data is due to random chance, and that's not good enough for our scientific experiments. And so we want to use the statistics test of a t-test to determine that the differences between these two data sets is not random chance. First thing we have to talk about is our p-value. Our p-value for this class is always p equals 0.05. What that means is that the probability of your data being randomly different is 0.05, which if we thought about that as a percent would be about 5%. That means that we have a 95% confidence that the difference between our two data sets is real, it's statistically significant, and it's not random. So that's why we use a 0.05 p-value. You can change your p-value. 0.05 is the one that most publications use. If you make it 0.01, that's saying you're 99% confident. That's really confident. Some publications like that, but 0.05 is the most common. So our p-value is set. What we're saying is we're looking for this level of confidence, and we can either find it or not find it. So if we want to be 95% confident that the difference between two data sets is not because of random chance, we use the t-test. So I'm going to show you my screen. I've got 3 different t-test calculators. We're going to put some numbers in the calculators. It'll give us a t-value, and then we compare our t-value to a table. And if it's above what's in the table, then we can say, okay, our data is statistically significant. It's different from each other. And if it's below what's in the table, we can't say that. It's might be chance. And so we have to accept our null hypothesis that the difference between our data could just be random, and we can't say with certainty that it is significant. So here is my screen. All right. This is the first t-test calculator. It's called GraphPad. They have a bunch of free calculators. It's pretty cool. We're looking for the t-test one. You can enter the amount of data you want to use, choose your t-test. We like unpaired because we're not looking at two expected amounts of data. We're looking at two data sets that we collected. So they are unlinked, they are unpaired. Then here you enter your data. So let's pretend that I wanted to figure out whether or not changing the height of a bird feeder made birds more likely to visit my bird feeder. So this year, I'm going to have bird feeder number 1, BF1. And when I put the bird feeder at 5 feet, I collected the data for the number of birds that visited every hour over the course of a couple of hours. So in the first hour, this is my raw data, I saw 10 birds. Then I saw 11 or 10 or 11. I'm just going to do roughly close numbers here. And let's say I did this for 10 hours straight. So that's my raw data. That's the number of birds that visited each hour. Notice that I'm not using the means. I'm using what I actually collected. Then over here, I have bird feeder 2. In bird feeder 2, I put it 10 feet up to see if birds like taller bird feeders. In an hour, I saw 9 birds, but the next hour I saw 15, and then I saw 8, and then I saw 14, and then I saw 7, and then I saw 12. So the variance was much greater. But on average, it'll be pretty similar. So I don't know yet whether or not those two data sets are statistically different. Then you go to calculate. Here are my results. Down here, whoops, there it is. I'm looking for the t. My t-value is 0.733. That's what I want from this calculator. I can pretty much ignore everything else. It's the t-value I'm interested in. I have to take that t-value and compare it to my table. So this is Rice University. They have a really nice website for different types of statistics tests. And I like this table because it's easy for me to read. So I'm using p equals 0.05 I'm going to draw on it. Hold on. There we go. So this is what we're looking at here is this one, P equals 0.05, and we set that. So that's the confidence level we're looking for. So I'm going to be looking in this column here, and I'm going to look where my degrees of freedom are. So my degrees of freedom is going to equal the number of samples I had minus 1 in my first data set plus the number of samples that I had minus 1. That's supposed to be minus 1 in my second data set. Right? And if we go back to my t-test calculator, it was 10 hours of bird observation. So that would be 10 minus 1. Plus, in my second data set, 10 hours of bird observation, 10 minus 1. So that's 9 plus 9. I'm looking for degrees of freedom, 18. So here's my degrees of freedom, 18. My critical T number is 2.1. I have to see now whether or not the T value I got from my calculator is bigger or less than that. So if we go back to my calculator, my T value is 0.7. Look at my, oops, where is it? Table, sorry, there it is. And that is definitely less than 2.1. So I cannot say that those two data sets are statistically different. Instead, I have to accept my null hypothesis that there is no difference. And I have to accept that because I can't say that there is a difference that's not random chance. So to get a number that is high enough to reject your null hypothesis, your variance in your t-test calculator has to be pretty high. And you can't tell just by looking at it. Like when I was looking at my data set, it looked pretty notable that I had bird visits that were like in 15 compared to the other one that only had 10 or 11. But the variance in that data set says that it's not statistically significant. Here's another calculator for you. This is social science statistics. This one is a t-test calculator for 2 independent means. Here, I'm going to put my raw data in the first box. Let's say this time I wanted to see whether or not a certain fertilizer helped a plant grow. So I gave one plant fertilizer A, and I gave the other plant fertilizer B, and I wanted to see if the difference in plant height was statistically significant. So after a couple days, I measured all my plants, and I'm entering my raw data for plant height. So we'll say that this is a plant height of 5 centimeters, 5 centimeters, 6 centimeters, 6 meters, and 4 centimeters. My other plants, they really grew better. We'll say fertilizer B was notably better. It was 10 centimeters, 10 centimeters, 14 centimeters, 14 centimeters, and 10 centimeters. So this is my raw data I collected. I'm entering it into my boxes for the different data sets. I have 5 enters. So that will help me calculate my degrees of freedom, which is number of samples minus 1 plus number of samples minus 1. So it'll be 5 minus 1 plus 5 minus 1. My DF will be 8. So my significance level is my P level, 0.05, great. I want it to be two-tailed, which means 2 data sets. And I'm going to calculate. Then I scroll down, and where is my T value? Right here. So my T value is what I'm looking for. Ignore all the ads. My T value is 6.1. We go for absolute numbers. The fact that it's negative doesn't matter. So 6.1. Go back to my table. My degrees of freedom is 8. The critical value is 2.3. So 6.1 is definitely bigger than 2.3. That means that I can say with confidence, 95% confidence, that the variance in between my data sets is real, and fertilizer B worked better. I'm statistically significantly able to say that it worked better than fertilizer A. So that's a second calculator for you. Here's another calculator. It's called MetaCalculator. It claims to be the best t-test calculator online. Sure, whatever. All 3 of them work great. When you use it, you'll want to do 2 sample paired t-tests, and we like to use raw data. And then this one's a little bit wonky. When you enter your data, you have two columns. So this is your data set 1, and then this is your data set 2. So you would enter all of your data for 1 in this column, and if you had more than 7, you would continue it here. So your number goes 7 to 8. And then for data set 2, you'd fill in this column and then continue it here. And then you'll hit analyze, and it will give you a t-value. You come back, you compare your t-value to your critical t-value chart. And if it is larger than the number in this column, you can say that you are statistically significant and there is a difference in between your data sets. I hope this helps. Email me if any questions, and have a great day. Bye.